correct so far?
Yeah, it's all correct.
For the most part, we double check.
So you guys, don't let the natural log of 2 bother you. It's just a number. It really is. And so when I look at that equation, if I'm going to solve for x, what I probably would have done is this. I would have isolated the, well, actually just separate those two terms on either side of the equal sign. How many trig functions do you see? 2. That's not fun.
No, it's not.
It'd be nice if only one.
You only see one?
No, it'd be nice if I could only see one. I'm not going to do that. Actually, I do only see one.
Oh, of course.
Use your
Matrix.
Which
identities of functions.
Which one? Which one?
Neither of them are
Square
squared.
both
so-
sides?
Ratio? If I divide both sides by the cosine of x, and maybe even divide both sides by natural
Of course you would.
log 2. Yes. Now I can see that the tangent of x is simply equal to this. Oh, but shoot, you know what, you guys? I can't answer this question. I don't know what the question is. Is it fine when the derivative is 0 over that interval of -2 to 6?
Well, they want you to find the
points.
critical points and then determine the absolute extremes.
Gotcha.
Would it be the negative tangent?
You know, it would is fine. I just put the negative sign on the other side.
It's
Well, yeah,
already-
because I multiply both sides by -1 and just change the signs where the negative sign is. And I think, Randall, it'd just be kind of nice to have the tangent isolated. So, you guys help me out with this. I didn't answer the question, darn it. I'm trying to find all critical numbers from -2 to, is that possible?
6.
Ah, shoot, I didn't do it. How do I solve for x? I said, ah, shoot, I didn't do it. How do I solve for x?
Take
Take the
Inverse tangent.
inverse
of-
tangent of both sides, and I see
negative
that
one
x is
over-
nothing
okay.
more than the inverse tangent. Whoops, I misspoke. The inverse tangent of -1 over natural log 2. Are you guys there?
Okay, that makes more sense.
Are you really?
Yes.
Everybody! No.
Oh.
What's wrong with this? I haven't done anything wrong, but I think there's something gravely missing. The understanding of the domain, I shouldn't say domain, the understanding of the interval over which I'm trying to find critical points is -2 to 6. And I think the inverse tangent of -1 over √2 is an angle between do you guys remember Math 8, trigonometry? Negative pi over 2 to pi over 2, but I gotta confess. The tangent is the angle has a tangent of -1 over √2, so I know I live in the 4th quadrant. Actually, I know this angle lives between -pi/2 and 0. So now I gotta find all the other angles between -2 and 6 that live, or that have a tangent of that particular angle. Did you guys see my point? So I don't know. What do you think? I don't think I'm done. I think we have a lot of work to do. Heavy sigh. Any idea?
I'm all excited because dividing by cosine. Now you divide by cosine.
Yeah, actually, it opens up the whole new world.
Right?
Yes. Well, actually, I'm trying to find all critical. Does the author say points?
Or numbers.
Yeah, all
Wait. Hold on.
all critical points. Yeah,
What section
of
is
f
this?
on the given interval.
What section is this?
4.1.
4.1?
I think so. Yeah,
You can't tell me this.
it's 4.1.
You just did. What number?
Number 49.
Okay, now I'm nervous.
You're nervous.
We have the test.
You just have to write the test. Oh, jeez. You guys, I have to confess, I don't often go into text carefully and just read it in detail. But I do see on page 226, the author is defining a critical point. And if you go in the very bottom box of that page 226, you don't need text, it's fine, just write down the page number 226. I have to emphatically disagree. This is not we're not trying to find critical points, we're trying to find critical numbers. If want a critical point, that's a point. That's a point, and what I'm gonna refer to, just give me 2 semesters. It's what I'm gonna refer to in the XY coordinate plane for which something interesting happens in the XYZ space. And so critical points for you and I are gonna be extremely important points in some region down here in the XY plane for which something on a 3-dimensional surface does something interesting. And so I really don't want you guys to refer to these as critical points. They're critical numbers, not points. They're values of x. How can they be points in 2 space? Do you see my... You get what I'm saying? So I'm really upset about referring to these as critical points. They're critical numbers.
What page was that on?
On page 226, the very bottom box, the author defines a critical point. He really should be referring to that as a critical number. I'll be honest with you.
Definition for critical number.
Well, I'm just saying that definition should be critical. No, he does not. I'm just saying that definition should be.
The book frames it as critical number, critical point, it's all the same thing.
But you understand the distinction? I mean, number is living
It
in
doesn't
one
sound
space.
like the author does.
Yeah, I know. Well, he'll contradict himself in 14 more chapters. Okay, so it talks about critical points and fractional space.
Aren't those technically points though, if instead of just the x value, he's asking for the x and y value? Then that's a
Ah, very good issue. I was going to say point. The fact is, Nabil, how can that be the case when we're looking at an interval just on one-dimensional space?
Is that one-dimensional?
Well, sure. When you talk about the interval from -2 to 6, you're talking about a subinterval of the one-dimensional real number line. You're talking about all real numbers between -2 and 6, including the
Well,
integers.
yeah, but you've got f of x, so it's also got 2 dimensions. I mean, they're only telling you to look at that interval, but you know, it's in two-dimensional space. Like, I mean, let's say one of your answers is
All right, let's go your direction. Let's talk about those so-called critical points in 2 space. What's interesting about them?
I don't know, maybe the graph does something funny.
You're right. Because I think at the critical numbers, something like this can happen. From -2 to 6, I'm making this up out of thin air. Maybe a curve does this. Where these 2 values of x, I'll call this one C1 and this one C2. Actually, how about C sub 3? I think they're kind of interesting in that the slopes of tangent lines are horizontal. Which, by the way, is exactly how you want to often generate critical numbers anyways. We set the first derivative function equal to 0. It's just that at this particular critical number, if I can use my language, that yields a local min. At this critical number, it doesn't. It's neither local min nor local max. At this critical number, C sub 2, I think it yields a local max. But critical numbers might or might not yield local extrema. That's the problem. And so why bother talking about this thing called a critical point when in reality, I don't even know if in general they yield local extrema. They might or might not. So what's the point of referring to that as a critical point?
Because they're interesting points on the graph.
But I think they're interesting in that when you set the first derivative function equal to 0, you generate those solutions. But I think that's for free when I talk about critical numbers. Why create more machinery to do something I've already done? I mean, as a mathematician, I just want to be really efficient with everything I say and everything I develop, everything I define needs to be very efficient. Otherwise, I think it's a bad definition. And so that's why I'm saying, you know, as a mathematician, I really don't like referring to these critical points. They really are critical numbers.
All right, follow-up question.
Yes?
Might be silly, but when you set the derivative equal to 0, you get your zeros of the basically tangent line, so that's where the tangent lines are flat. When you might get more than one point from an x value.
Oh, yeah. Oh, yeah.
How do you know whether, just by the number itself, whether it's bigger or smaller than the second one, whether it's going to be a local max or a local min, or do you know whether those numbers are going to be local max or local mins?
I will by testing them.
Yeah.
Oh,
first
testing them.
derivative test.
Yeah, something called the first derivative test, or the second derivative
Yeah.
test, whatever that is. We'll talk about it tonight.
Oh, so, okay, gotcha.
It's the same thing, except you set the so it's called cabin.
Okay.
So you guys happy I've answered the question in green?
No.
I'm not happy either. I don't think I've done anything close to it. So if you guys don't mind, I want to talk about this angle. Because I think this angle x, actually, can I change this, guys? Oh, shoot. slight change in language, just so I can talk about this more clearly. Do you guys mind for not knowing you? Excuse me. Because I want to come over here and talk about the XY coordinate plane. Here's the x-axis. Here's the y-axis. I think that angle theta is simply the angle in the fourth quadrant whose tangent is negative 1 over root 2. Excuse me, negative 1 over natural log of 2, whatever that is. If you don't mind, can I talk about its reference angle? There's an angle theta, where theta is equal to the inverse tangent of 1 over natural log of 2. I think that angle right there is sitting right down here. And if you guys don't mind, I can interpret that as negative theta. What's this angle?
90 minus.
2 pi minus
Negative pi over 2.
minus.
I heard that. Negative pi over 2.
Oh.
But pi's around 3. So I think this is around negative 1.5. I'm being a little crude. I don't want to pull up my calculator. I think it's roughly negative 3. Is there another angle in here that has a tangent that's negative 1 over natural log of 2?
But it's not in the domain of the inverse tangent.
That's true. But answer this question directly. Is there another angle here in the third quadrant whose tangent is negative 1 over natural log of 2?
Yeah.
I can't hear you.
No.
Why not?
Oh.
Why- I agree with you, David. Why not? Because the tangent of any angle in the third quadrant is
Positive.
positive. Ah, shoot, there isn't one. But I think I've gone all the way further back than negative 2. I think I'm done. Because that's about negative 3.
Oh.
So I think from negative pi up to 0, I think there's only one angle that has equality. Here it is. I'm trying to list all my critical numbers. In that interval, I think one of them is going to be this. Oh shoot, let's see if there's any more. Let me rotate all the way up to, how about 1 full revolution? From the positive x-axis, rotating 1 full revolution, what's that angle in standard position?
2 pi.
2 pi, which is approximately,
360.
well, to agree, as a number is approximately 6.28, something like that. Oh shoot, I was supposed to go to 6. So let's check it out. Do you think there's an angle in the second quadrant whose tangent is negative 1 over natural log of 2? I'll ask that again. Do you think there's another
Yes.
angle? Yes, I think there is. I think there's an angle over here whose reference angle is nothing more than theta. And so I think in green, this angle in standard position is going to be nothing more than, you took too long, you shouldn't let me finish my breath.
2 pi minus.
Say it again.
2 pi minus.
Say pi.
Pi minus.
Oh, just 1 pi minus. Yeah, theta, the reference angle, which is the inverse tangent of 1 over natural log of 2. Ah, shoot, you guys, in blue. I think there might be another angle right here in the fourth quadrant whose tangent is negative 1 over, yeah, Nabil?
I have a question.
Yes.
Why is your theta right there negative inverse of tan?
Here's why. Do you agree my reference angle is just inverse tangent of 1 over natural log of 2?
No.
It's just that when you look at the solution here, I'm looking at an angle that's clearly in the fourth quadrant.
Yeah.
It's the inverse tangent of negative 1 over natural log of 2, so I know it's sitting right there in the fourth quadrant. And so that very first black solution I have over there, you can write exactly as this. It's correct. I just rewrote it differently as the opposite of that reference angle. I think what you see of black right here is equivalent to what I have over here.
Because tangent is an odd function.
Yes, I have to confess, it doesn't necessarily as inverse function is, but you're right. Good
Okay.
Nabil, you there?
Yeah, I got it.
Now, I'm nervous, you guys. I really am. I don't know the answer to my next question. Is there really an angle in the fourth quadrant between 0 and 2 pi whose tangent is negative 1 over natural log of 2 that still is in my interval? I don't know, but if there is, then I think it's got to be this in blue. It's got to be 1 full revolution backed up by that reference angle. Now, the reason why I'm saying I'm
I
nervous
think
because,
that that's in there. Let's see.
well, that's my whole point. I think at this point, I probably have to take out a calculator and number crunch this and see if this angle really is less than 6 radians. And I really don't even know what the answer is, Brad.
I'm checking right here.
I'm truly being honest with you guys. I can't do that in my head.
shocked.
That is shocking.
I
No,
know in
no,
my head that's a fairly
no,
shallow
it-
angle.
It's, I'm getting 6.25.
Okay,
so-
now wait, if Brad's saying when he approximates this as approximately
Yeah.
6.25,
Yeah.
I'll reject it. It just does not move my interval from -2 to 6. Gosh darn
I
it.
got 5.31.
You did?
Ooh. It's a battle.
Math fight, math fight.
Are you checking you guys your modes?
Yeah, I might have not put in parentheses, so let's see.
When I come up with 2 pi
I'm sure.
minus inverse tangent.
Whoa. I got something way off that time.
1 divided by natural log of 2, close. I come up with, 5.3.
Yeah,
So Brad, you can say.
I'm wrong.
Almost a shock.
I'll get rid of this cross. I like that answer. Ah, shoot, you guys, I still didn't answer my question. What was the question?
Critical points?
No.
Critical number.
Well, okay, you're right. I found it. You're right. I agree, David. But the overall question, the bigger question is. No, find the absolute extreme over the interval from -2 to 6. How do I do that?
Plug those in
To what?
to your original equation.
And what else?
Solve them.
What else do I plug in? The endpoints.
Yes.
So I think I need to take my original function f, eval at the left endpoint, eval at any critical number in between, like these three. Oh my goodness, I'm not doing it, am I? Jeepers. Hold it. F of -2 is 2 to the -2 times the sine of -2. But f of this is 2 to the negative inverse tangent of 1 over natural log of 2 times the sine
Radians.
of the negative inverse tangent of 1 over natural log of 2. Then I got to take my function evaluate the green critical number. Then I got to take my function f and evaluate the blue critical number. And lastly, you got to take my function evaluate that
6.
6. I agree. Do you guys mind if I don't finish? I mean, now isn't it just a calculator game? I gotta plug these numbers into my function f, see which was the biggest, see which was the smallest, and I found the absolute extreme. Do you see that?
Yep.
Wait, does the textbook, like explicitly say including the endpoints? Like, because how are we supposed to know if the endpoints are inclusive or not?
Because it's a closed interval.
Oh, really?
Because it's a closed interval, they're asking me to find the extreme.
Oh, okay, alright.
And the extreme value theorem says I'm guaranteed that they exist.
Can you do 39 also?
I hope we can.
Wait, according to which theorem does it say that you're guaranteed?
The extreme value theorem says if your function f is continuous over some closed interval, there's an absolute guarantee.
Or no,
There exists an
37.
absolute max and an absolute min. Doesn't tell you how to find them.
What if it's just a horizontal line?
Good point. Then I think every y value is the absolute max, and I think every y value is the absolute min as well. Think about it, Nabil. Watch. I think C yields an absolute max over some interval I if f of C is greater than or equal to f of x for all values of x over some interval I. It's a closed interval, by the way, closed interval. And so if you got a horizontal line, is it not true that every single value of x in that interval
It's greater than or
satisfy that condition? Also, I think every value of y is going to be an absolute min as well. Just because of that.
You mean every value of x is going to be an absolute min?
Rephrase that. Every value of x will yield an absolute min.
Okay.
There's only one absolute min, though, and it's that y value that's a constant. Brad, I'm sorry, did I interrupt you? Did you
Oh.
change the number?
Change the number. 37.
So 30, what section are we in?
Same section, 4.1.
4.1.
So, yes, Christian.
Is that an I?
Yes.
An anonymous person on you.
in interval line. So you guys, 37. Okay, gotcha. Use a graph utility for your results. So I've got a function f defined as this: 2x to the x on 0. 2x to the x, 2x to the x. I think, hold on, let me double check.
Yeah, you're right.
Good. So, question number 1. Find the critical numbers over the interval from 0.1 to 1. Well, in English, I'll close my pen. Using words. What the heck is a critical number in words?
It's a point of which, or not a point, it's a value of x for which the tangent line at that,
Value.
the tangent line, I'm not gonna say point. Or when the tangent
I'm not gonna
line
jump on
slope
you.
is equal to 0.
Or,
When the tangent is horizontal.
when it's also...
When it's changing, when its slope is changing.
Well, how about undefined?
Yeah.
See, I think by definition, a critical number is simply a number for which your first derivative function is equal to 0. It means you have a horizontal line, asymptote. Or where the derivative function is undefined. Do you guys agree?
So you only have 2?
Only 2 conditions.
Okay.
So I need to make sure I check when the first derivative function is equal to 0 and when it's undefined. Well, if I'm going to find critical numbers, I guess I'll need to compute the derivative function. And so if y is equal to 2x to the x, how the heck do I find y prime? Logarithmic differentiation. Because this function is neither exponential nor power, but because the variables both in the base and exponential position, I have no choice. I got to dive in and take the natural log of both sides.
So you couldn't still do like the chain rule on one side with logarithmic differentiation. So like if you did 2x to the x times ln of 2x.
You know, I can do that, Brad. I mean, that's the way I traditionally do it. But that's more like saying that y itself is equal to e to the natural log of 2x to the x power.
Okay.
As an alternative way of actually performing a logarithmic differentiation.
Okay.
Now, I confess, when I exponentiate and compose with a natural log function, you got to look at what I'm writing on the board. That looks complex. But I can uncomplex it, in a sense, by using my MathB properties of logarithms. After all, I think when it comes to the natural log of this thing raised to a power, that can be interpreted as a natural log of that thing times that power. Now you have to confess what's sitting in front of me is nothing more than an exponential function on the right-hand side. And I can apply my typical techniques for differentiating exponential functions. As a matter of fact, I think y prime, since y is equal to e to some power, is just simply equal to e to the same darn power. Nothing changes.
But you take the derivative.
You gotta take the
Thank you.
derivative.
It's just that the chain rule says now I'm going to multiply by the derivative with respect to x of whatever the heck that power was. I can't write it. It's just that in differentiating that beast, I guess what it really means is I'm going to have to use the product rule. So I've got e to that nasty looking power. Now differentiating that product, doesn't that give me the first times the derivative of the second plus the second times the derivative of the first?
So we're not putting the 2 in?
Yeah,
Oh, because it
Maybe 1 over
cancels
2x?
1 over 2x.
If you exist, 1 over 2x, chain rule again says multiply by 2.
Oh, okay.
I never do that in my head. In my head, I see this as natural log of 2 plus the natural log of x. So the derivative of the natural log of 2 plus the natural log of x is nothing more than the derivative of the natural log of x. But you look at it any way you like. I'm going to rewrite this mess. I guess that means that y prime is nothing more than, I don't know, is that 2x to the x again? Times 1 plus the natural log of 2x. But now wait a minute. if this really can be considered this way as exponential, then certainly e to some power is never going to be equal to 0. It is certainly always defined. So I think y prime is always, well, I shouldn't say so fast. At least in terms of factors, always defined. I think the only thing you and I need to worry about is when this factor is undefined or is equal to 0. And I think y prime is equal to 0 simply when the second factor equals 0. Or shall I say the natural log of 2x is equal to -1? Or shall I say 2x is equal to e to the -1? Or shall I say x is equal to 1 over 2e? And I think y prime is undefined simply when the second factor is undefined, but clearly that's going to happen at x equals 0. So I guess the only two critical numbers I have are going to be 0 and, I've lost it, 1 over 2e. That being the case, shoot, that being the case, I forgot the question. The question really is this. How do we find absolute extrema over this closed interval? Well, I'm going to take my function f, and I'm going to evaluate at the left endpoint, I'm going to evaluate at the right endpoint, and I'm going to evaluate my function at any critical number that lives between the left and right endpoints. And by the way, e is approximately 2.7, or how about being 3? Approximately 3. So I think 1 over 2 is approximately 1/6, which clearly lives between 0.1 and 1. I think I better evaluate my function at 1 over 2. Do you guys mind now if I don't finish answering the question? Now I'm asked to slap in these 1, 2, 3 values for us into this expression and see which one's the largest, which one's the smallest. That'll determine the absolute extreme.
And
Brad,
you just,
you asked. Is that okay?
No, yeah, that's,
and you get rid of anything.
I did
that's in the
something weird.
middle. You get rid of anything that's in the middle?
What do you mean by that, David? I don't understand.
Well, you said take the maximum and the minimum, but you have 3 values there.
Okay, true. I just think one output's going to be larger than the other two. One output's going to be smaller than the other two. And so, yeah, there might be an intermediate value one, but it doesn't make any difference. I'm just trying to find the biggest and smallest output of the function over that closed interval.
Gotcha.
Did you only do the 1 over 2e because they're all basically the same thing?
No, that's not the reason at all. Actually, I did not evaluate my function at this critical number because when you look at 0, it does not live in this interval. Do you see my
Number.
thank you.
But what about like 2x equals e to the...
Now, wait a minute. I think everything you see with my check mark here, here, and here was merely solving that equation. So in the end, I found that x equal to this.
Okay.
Come on, you guys. These are good questions. Anybody else?
Go over the quiz.
Oh, I forgot the fun quiz. Can I see it? Can you give it to me? So we are all now graduates, so we can actually make copies and understand what's going on. Come on, what's that a good quiz?
It wasn't bad.
Yeah, just grab it. Right there. Here you go.
Would you happen to have my test?
Your test? What happened? Oh, I'll check during the break. I'll check.
All right.
He's got it.
Oh, thank you. Thank you. All right.